All right, question number 13. We want to assume P and Q are odd functions, and we want to prove the integrand below either is even or odd, and then give the value of the integral to show how it can be simplified. All right, so we are told P and Q are odd. All right, so we're going to substitute a negative x in for x. So again, talking about symmetry, we know the rule for odd is if we plug in f of x negative and we get a negative f of x out. Okay, so the negative of the y value. So I know that when I plug in a negative, I get out a negative because it's odd. And so we are looking at the integral from negative a to a of p of q of x. So if I plug in a negative x, which they're showing me here, q of x will become negative, and that negative x will come out to the front. So negative inside turns into a negative on the outside. B looks good, and this one has both. So B looks good as far as following the property of being odd. Given the result of the previous step is P Q of x even or odd, it will still be odd based on the previous. Alright, give the symmetry of, given the symmetry of P of Q of x, solve this. So since this is odd and we're going from negative to positive of some value, this would be equal to 0. So just the property. Integral will be equal to 0 because it's odd.